Ladies, gentlemen, and good people of the world, Brad the Guitologist here with another excruciatingly exciting video for you. Today we have a 1956 Fender Bassman Model 5E6. This particular example belonged to the bass player of Tennessee Ernie Ford. If you've ever heard of him, some of you old timers may. Some of you young chappers can go look him up. Anyway, the father of the current owner bought this in 1960 or 61 from Tennessee Ernie Ford's bass player, and he actually used it with a bass in Tennessee Ernie Ford's band apparently for a little while. We're gonna turn this thing around, get a good look inside. We're gonna go through the schematic. We're gonna do all the things that we normally do on this channel, but this should be a particularly special one since they didn't make a whole hell of a lot of these, and this is an original 1950s Tweed Bassman. So if that sounds like something you guys would be interested in, which I know you will be, please stick around. The 5E6 and 5E6A Bassmans, and also all the Bassmans up until what, 1960, had 4 10-inch speakers. These are Jensen P10R speakers. They are the original speakers. We'll get a closer look at them in just a little bit. They have been reconed in their life. Whenever the current owner got it from his dad, it had been in storage for a long time, he said, and the speakers had been just eaten up, I guess, by mice or what have you, as they often do if you don't attend to them. And he had them reconed, but first he had actually taken this thing to another technician, he said, and they put in some like pile speakers. And as soon as he said that, I kind of gasped. I said, ooh. I said, hopefully you still have the originals, and he said, yeah, they're back in it and they've been reconed, so that's a real plus. So that'll be good to get a look at the original speakers in it. They are date coded 1956, as we'll soon see. This model has dual rectifier. This is known as the dual rectifier Bassman. It has 2 5U4 rectifiers. It was, as far as I know, the first Fender amplifier that featured 2 rectifiers, and might be the first guitar amp to feature 2 rectifiers. I'm not entirely sure on that, but that could very well be. Somebody pipe up in the comments if you can think of an earlier amplifier for guitar that had 2 rectifiers. Let's get a look at the controls. Okay, the controls on the 5E6 consist of a ground switch, fuse holder, off-on switch, standby switch, and this is actually one of the reasons that this was brought in. The standby switch, the customer says, is real finicky, and actually I can hear something weird going on with that switch, so we'll probably end up changing this switch. It's most likely faulty. Jewel knob, presence control, which is negative feedback based, bass and treble. There is no mid-range like on the later version of the Bassman. And there's a volume 1, a volume 2, and a bright and a normal input. Alright, here's a little better look at the inside of the rear of the cabinet with the speakers. And again, these are Jensen P10R speakers, and they are date coded the 39th week of 1956, at least on that one. I think on all of them they're fairly close. That one's 45th week, so this might actually be an early 1957 amplifier. It's possible. 45th week on that one. And let's see, it's gonna be hard to get a look at the other code. Whoops, it's gonna be hard to get a look at the other code. It's actually the 39th week on that one as well. Kind of hard to see, but it's there. But they are all original. If you'll notice also, let me back up here. The bottom 2 speakers have bells, and the top 2 speakers do not. You can just see the Alnico magnets without the bells on, and that's because there wouldn't have been enough clearance for the tubes to fit with the bells. As far as cabinet construction, this is finger jointed pine on the cabinet. You can see the knot right there, which is a dead giveaway for pine. But I think the baffle is made of probably birch plywood. That's what it looks like to me. Birch plywood. But let's get the let's get the back door off of this thing and get a little closer look at the tubes in the circuit. Actually, before we take the back door off, let's just walk around and get a overall view of the condition of this thing. Now you can see the Tweed is worn in the corners, as you would expect on a 1956 Tweed Fender. We do have a couple of extra holes, as if they had a different handle maybe on this at one point in time. More wear over here on this corner, and it looks like maybe some moisture had gotten to the Tweed up here at some point. This should probably be glued back down and re-lacquered. That's what I would, if this was my amplifier, that's what I would do with this little area right here. That's going to protect the Tweed. It's going to keep it from fraying anymore, and that kind of repair is not going to detract from the value of an amplifier like this. A little bit more wear up front on the bottom, but overall in great condition. This is the original grill cloth, I do believe. Original logo. Got a little bit of a puncture right there. Nothing major and nothing that detracts the eye or anything like that. Just a beautiful, beautiful amplifier. Let's get the back door off and take a look at it. Alright, here's our asbestos lined back door. That's what that white stuff is asbestos. And it's not as dangerous as everybody makes out. You know, as long as it's not like airborne or something like that, asbestos is pretty okay. I mean, you're not in any danger from, you know, breathing something from a Fender amp. This thing looks like, other than the power capacitors, which are some Illinois, and we'll probably end up replacing these. Let's just get a look here. I'll shut up for a second and we'll just look, admire. We do have the yellow Astron caps. There's another electrolytic right there that's got to go. She's been in here long enough, served her purpose. It's nice to see these, but at the same time, they're not going to do the tone any favors. Just in real good condition overall. This also affords us a look at the tube complement. We have a couple of 5U4s, as I mentioned before. We have a pair of what look like RCA 6L6s right there, gray plates, and we have a trio of preamp tubes. Now on the 5E6 Bassman, the preamp tubes are kind of strange from what you're used to seeing on most amplifiers, guitar amps, in that we have a 12AY7, a 12AY7, and then a 12AX7 in the phase inverter. So kind of backwards from what we're used to seeing, but they've kind of designed this with an eye to keeping the amp clean. One other thing before I forget, here is the serial number on the chassis, BM. This is number 1230, if anybody's counting. That should be the 1230th Bassman made, I would guess. The serial number is repeated right here. Let's get a good look at this. And man, that's in good shape. I don't think that's a replacement either. That's the original one. Look at that. 5E6FK. Serial number BM01230. But yeah, see what I mean? 12AY7, AY7, and an AX. Now the 6L6s that this originally took were the GBs, not GCs. There's a difference in the specs of the GB and the GC. You can slap GCs in it and they will work, but it originally would have come with glass bottle 6L6s. Yeah, let's get this thing inside and give it a whirl. A couple other quick notes. These screws that are holding on these back doors are modern screws, and they really don't look the part. You know, they stick out like a sore thumb and have just no patina on them, and I think we could probably do better than this. I'm sure I've got something in my parts drawer I can replace for this customer, and I won't charge him for that. Just try to find some decent looking screws. Also, the wiring on the cabinet leaves something kind of to be desired. It looks a bit messy for one, and I don't like the wire they used for this. I mean, it's good wire, but look at this, you know. It's just, this amp deserves better than that. You shouldn't have to look in the back of the amp and have your experience, your otherworldly, heavenly experience detracted from by something like that. So let's do something about that too while we have this thing. All right, let's take a look at the schematic of this thing. And as I mentioned before, there is a 12AY7 up front here. It's split into two halves, and each half is taking care of one of the channels or inputs. There aren't very many differences other than this little bright cap right here on the bright channel. What this does is it passes some of the highs around this potentiometer. So no matter how much you turn it down, the highs are still going to get through. We do have a shared cathode bias resistor and bypass capacitor on these first stages here. Moving along through, it gets a little confusing because it looks like it goes in two different directions. It looks like the signal goes from here off up this way, and then also from here this way into the next tube, but that's kind of not the case. Really what the signal does is it sees a 10 meg resistor right here and it goes, oh, don't really want to go that way, so it goes here instead mainly. It gets amplified and goes to this cathode follower, so the signal comes out the cathode in this instance rather than out of the plate. The reason they do this usually is right in front of tone stacks. That's to prevent insertion loss through the tone stack. But what we can see here is we have a treble pot. We also have a bass pot over here, and then on the other side of these pots, it goes along to the next stage, which is the phase inverter. But we'll also see here this 10 meg resistor, there is a pathway for signal to actually go backward through this 10 meg and back into this input. What this is a feedback into the previous stage, and this is an attempt to try to keep the amp cleaner. This might be something I can talk to the customer about. This is a 1956 Fender Bassman. I don't want to go messing around too much or screwing around or modifying this thing greatly or anything like that, but potentially removing this 10 meg resistor right here could do the amp some favors for guitar purposes. So that might be something to think about, and if this 10 meg resistor is in the circuit still, we might talk to the customer about possibly removing that. I'll stick it in a baggie. He can put it in the back of the amplifier. You know, if he ever decides to sell it, which I doubt he will, because I mean this was Tennessee Ernie Ford's bass players and his dad's, you know, Bassman, so I doubt he'll want to get rid of it. But the next owner, eventually, you know, his estate or something may want to sell it, so they'll have that resistor. I mean, if they want the exact resistor, it will always be able to. You'll always be able to put this back to stock, you know, with the original resistor that way for persnickety people. There's some people who will even be like, "Oh, you've touched the solder." But you know, there's no pleasing those people anyway. So to hell with them. If you think that you can get a better sound out of this amplifier by removing this and keeping it with the amp, I see no harm in doing that. So that might be something we discuss, and I'll show you why this would actually work somewhat to keep the amp clean. Because if you think about the signal, if it goes positive first, if you think about a sine wave going up and down like this, if it goes positive at this point, it's going to go negative when it hits, it's going to flip when it hits this plate. So going through here, the cathode follows, so it's going to still be negative here. So you have a positive at this point, and you have a negative at this point. So when it feeds back through, you're mixing the positive and negative, so you're getting some cancellation of some of the frequencies that can pass through, say, this capacitor right here, for instance. So hope that explains it. Moving through, The phase inverter, once again, is a 12AX7 phase inverter, which, you know, again, is kind of odd. Usually you see 12AY7s, if anything, or AT7s in the phase inverter position, and the 12AX7s up front. This should be interesting to see what this sounds like in comparison to some of the other, you know, later Bassman videos that are online. So we'll wait for that to see what that sounds like. But let's see. Yeah, not much else to speak of. Again, we have, this is actually labeled a 6L6G instead of a 6L6GB, which is what we saw on the tube chart inside the amplifier. So that's kind of interesting. Of course, this is the 5E6A, which is a revision of the 5E6. The actual amp that we have, I think, is a 5E6. So this might not follow it exactly, but we'll see if there are any differences and try to document those as best we can. Again, we have a dual rectifier here, and pretty much what we have is these rectifiers are just in parallel. So it's really, you know, it's not that much different than having a single rectifier, except I guess you have you sort of have a backup, and this may prevent some sag that would be associated normally with a single rectifier. So these two rectifiers are probably able to push voltage a little easier than just one by itself. So you know, when you hit a note, it's not going to draw down the voltage quite as much and be as much of a stress on two as it would have on one. Of course, that's going to require a bigger power transformer winding on this winding in particular, because you're going to have on the 5-volt winding, you're going to have more you know, current draw. So you got to be careful about that if you're designing something like this. You know, interesting that it has two 5U4 rectifiers. But yeah, pretty much that is the amplifier. The standby switch, again, this is faulty, so we're going to have to replace this. We will go ahead and check the bias and everything while we're in here, of course. But yeah, that's pretty much all there is to report. Let's check it out. Okay, here we are with this Bassman out on the desk, and we can get a little better look at the innards here. All of these capacitors we are going to change. I've discussed this with the customer, and he's good with it. All of these little electrolytics are going to have to go anyway, and at least a couple of these Astrons are definitely bad, because I can already tell I'm getting some DC leakage onto at least one of the pots. And you know, when one of these goes bad, the rest are really soon to follow. These Astrons are not known for sticking around this long, really. So we are going to replace those with some Sozos. They've already been ordered and have come in, and we will get those in momentarily. But we can take a look here at the date codes on some of these. This is 1955, 30th week on that one. 1956, 26th week on that one. 1956, 13th week here. Moving through, here are these Illinois capacitors. We are going to replace those also, and I've spoken to the customer about that, and he has chosen to go with some F&T caps, which I think is probably going to be a good bet for this amp. We have another capacitor over here, which is part of the bias circuit, and it is actually date coded 1952, 39th week, so that's interesting. This one sat on the shelf for a little while. We also have over here, this is a selenium rectifier. Selenium rectifiers are pretty notorious for basically going bad. Any of these ones from the 40s and 50s, which is what they used back then in the 40s and 50s. They didn't really have silicon rectifiers or diodes yet. They used mainly these in these amplifiers, and we are going to replace that with a silicon diode. We'll leave this in place and just clip out the leads. It'll still be there, but we're just going to solder in a new rectifier diode right there in that position. So those are some of the things we're going to do. We're also going to go ahead and change, of course, that standby switch, which is faulty. replace the power cord, and then we'll fire this thing back up and see where we're at on it. Alright, here are the capacitors that we've chosen for this thing. These are the Sozo NexGen capacitors and also the F and T's. On these Sozos, you know, I'm not usually a big proponent on all the, you know, upper end capacitors. I don't buy into a lot of that kind of hype, really. I mean, I usually use the red type Panasonic capacitors, or just you know, orange drops or something like that, and they've always done really well for me without spending you know, 10 to 20 times usually what you'd pay for some of that stuff. But you know, I did advise the customer for no more than these are going to be in total for this amplifier. It's probably a good investment, because if he ever did fall on hard times and have to sell this amp, he would probably get top dollar by having the best stuff in here. There are some persnickety people out there, and there are enough of them that you know, he may get a little bit more, or at least get top dollar for this amp if he ever did come to sell it. So this is what we're going to put in there. Alright, I've wired in the new power cable on this thing, and what I ended up doing was I just took the bad switch that was over here and I moved it over to the ground switch position, since we were going to take the ground switch position out anyway, and it's just going to be doing nothing. So the bad switch is now right there, and the ground switch, I just clip the end lead off and use it for this switch. So that saved the customer a switch. Alright, we've completed the cap job, and over here are all the casualties. The only one that I changed the value of was this 250 microfarad bypass capacitor on the first stage. I have changed that to 100 microfarad. We're going to try it with 100. Reason being, this was, you know, again, originally designed for bass, and a 250 microfarad is pretty darn big, and is going to give you a lot of bass that is kind of on the useless side for guitar, I do believe, especially right up front like that. So we're going to start with 100 and see where that takes us, but we're going to turn our attention now to finding a couple of tubes. We're going to go with a 12AY7 in this second position, and we're going to find a nice quiet 7025 or 12AX7 for the first position. Okay, I just want to show you something real quickly here about the diodes. In this amplifier, it originally was a selenium rectifier diode. This diode has the same sort of symbol with the cathode being at one end. And here's like, if you're curious about what you know, this normal symbol is, the cathode is designated, the negative side is designated by this line, and then the triangle side is the anode or positive. On this one, you see the triangle side over here is indeed the positive, and the negative is over here. That's the way it's written on this schematic. Now on later Bassman, though, you notice the difference. You see the diode here. The symbol is actually reversed, where the negative side, well, they still have it negative up here. That's where the negative voltage should be read. But they have it facing they have at least the line side facing the actual transformer, where the voltage is originating from. So you see there, this end is facing the transformer, and on the later blackface schematic, and this earlier one, you have it facing the other way. So you got to be careful if you're replacing one of these old selenium diodes. You need to actually flop it around backwards from what you think it would be. Okay, we have the new silicon diode in there. When you change to a silicon diode from a selenium, the selenium has a different voltage drop through it, so you may need to adjust the resistor values. You can see here we're at negative 48 volts, whereas with the selenium we were at about 41.5 negative volts. So we may need to change some resistor values here. We'll experiment with this and see what we need to do. Okay, so I did go ahead and change this 54K resistor in the bias circuit to a 20K instead. And that has actually gotten our negative bias voltage down to about 35 volts. And the reason I went down below the recommended 41 negative volts on the schematic is because we're using 6L6GCs right here as opposed to the 6L6Gs that this originally would have come with. The 6L6G has a lower plate dissipation maximum than the 6L6GC, so that's why we went with the little bit of a lower negative bias voltage. And as a result, we're dissipating about 19 watts per tube on these output tubes. Alright, so that completes the service on this amp. Now it's time to put it back in the cabinet, plug it in, and see what she sounds like. Alright, now we're going to have to turn our attention to this atrocious speaker wiring. Look at what they've done here. Besides just taping these together like this, and this was supposedly professionally done too, but I just don't understand it. They've taken this wafer and they've hot glued it onto the speaker, and why didn't they just put it on the original terminals? I don't understand that shit. I mean, who does that on an amp like this? I don't, man. Oh, yeah. Anyway, I guess I'm gonna have to go through here and do the job that they didn't do and remove the leads and put them to the original terminals the way they're supposed to be, and we'll replace this wiring also. Okay, so this cabinet is finally rewired. And what I'm going to do now is actually test the positive and negative and make sure that these weren't mixed up by whoever did the recones on these speakers. But you can see that looks a hell of a lot better. I mean, I don't know why they would have had all of that mess. And here's the wiring harness. I mean, this is all the crap. I just don't know why they had those little wafers in there like that, but you know, it is what it is. We're going to change it, so whatever. But we're also going to test how to determine polarity on speakers like this. I'll show you how that's done. Okay, the way to determine polarity on speakers, the easiest way is to get a 9-volt battery, attach a couple of gator clips to it, have the green attached to the negative terminal. So I'm going to go through these speakers and attach to what I believe is the negative. There are some markings on the speakers that it looks like were made by the person who did the recone, so I'm assuming they got this right. But we have to double check it to make sure. If the polarity is off, you might have one of these speakers that's coming in while the other one is going out. So you have kind of this thing going on, and when they aren't working together in unison, you're not getting the most out of your speakers. You're getting phase cancellation essentially. What we're going to take a look at the cone here. When I apply this lead to this terminal, we're going to see whether it comes in or goes out. If it goes out, then it's correct, and that is the positive. If it comes in, then these are wired backwards. So that is going out. See that? See how the cone is going out when that's applied. So that one is correct. Let's check all 4 of the rest of these and make sure that they are correct, and then we'll be ready to go to wire it up. Okay, now this is wired up. All we need to do is attach the jack and we'll be ready to go. Alright, I thought we were going to be doing a demo, but I've got this thing back up on the bench, and here's why. Whenever I turn the thing on, all it does is just hum. Unplugged the speaker cabinet, plugged another speaker in, and it's fine. So the problem is somewhere in the speaker wiring now. Maybe that's why they changed those terminals. And also, when I test it after wiring it up, I'm getting, you know, roughly 2 ohms, which is about what I would expect for 4 8-ohm speakers in parallel. But something's definitely going on, and here's how I know that. If I go from the positive, for instance, and just touch the basket with the other lead, it's a dead short. So, and you know, like I said, I went through very slowly, and I knew that was a possibility of getting shorts, because it always is with those kinds of terminals, but I'm not sure where I went wrong. So I'm going to have to go through and troubleshoot and figure out where I went wrong with this speaker wiring now. Alright, I think my source to finding the problem is going to be or my method here to finding the problem rather, is going to be to split these in two. So I've disconnected these bottom 2 from the top 2, and we'll measure the bottom 2, see if we can't find the source of the grounding that we've got going on. Okay, I've measured the top 2, and I'm getting about 4 ohms. I've measured the bottom 2, and I'm getting about 4 ohms, which is what I would have expected, splitting those apart like that. So what I'm going to do is fire up the amp with just the top 2 plugged in, and see if I get any sound rather than just hum, and then I'll try the same thing with the bottom 2. I'm not going to turn it up, because these really aren't up to the task of handling the full power of this amp, but it'll at least tell us, you know, hopefully where the problem is. Alright, fired it up with only the top 2 attached and no sound at all, so let's attach the bottom 2. Okay, here we are with the bottom 2 hooked up. And we're getting sound out of those. So the bottom 2 are fine. The problem is somewhere with one of the top ones. Alright, I removed enough leads to test both of those top speakers independently, and they both work independently. And then I kind of got to messing around. All of the positive terminals are attached to the basket. So the basket is positive on all of these, including the bottom ones. But the difference is, on the bottom ones, when I separated those out earlier and I tested just the bottom ones by themselves, they weren't up here on top. And I got to looking, and if you look up in there far enough, you'll see the transformer, I think, is actually touching the basket, perhaps, of that one speaker somewhere up there, I think. Yeah, see, the power transformer. It's going to be real hard to see, but I think that power transformer is actually touching that speaker basket and screwing the whole shebang up. So that's what it was. So that it was actually working fine without the chassis in. So if you basically swap the leads, I think on the top speakers, I think we're going to get this thing to work. Yeah, you see right there? You can see where this thing has been rubbing probably for a long time, off and on. And there's the corresponding mark on the speaker. So yeah, this is definitely something to look out for. I'd say when they redid these speaker cones, they might have run across the same problem and perhaps weren't really sure what the problem was, so they put those terminals on and discovered, oh, these terminals are solving the problem, and maybe didn't really isolate it down to that. So who knows, whatever. But I guess there's no grommets on the positive terminals, isolating them from the baskets on these speakers, so that's something to keep in mind if you have one of these. Alright, let's try it again with a Strat, but this time with a 12A V7 and V1. I don't have any 12A Y7s apparently. I thought I probably should have had in my stash, but I could not find one. A 12A V7 is very close on the gain factor though, so let's see what it sounds like with that. That sounds fantastic in the room. I'm not sure how it's coming across in the recording because I'm using some different miking techniques this time just as an experiment, but sounds great here. Next, let's check it with a bass guitar. You never really hear anybody demonstrate these with a bass. Alright, so that's a 1956 Fender Bassman. Hope you guys have enjoyed this video, and for now, y'all take care.